A body is thrown vertically upwards. If air resistance is to be taken into account, the time during which the body rises is. So a body is thrown vertically upwards. So it will take some time to reach the maximum height. Let that time be t1, and the time of descent, that is time to again come back to the ground, suppose that time is t2. So let us find t1 and t2, then we will compare it. Now the air resistance acts opposite to velocity. So when the ball is going up, the velocity is in upward direction, but the resistive force is acting in downward direction. So suppose the retardation due to resistive force is A, and the acceleration due to gravity is also acting downward. So during upward motion, acceleration is equal to minus of A plus G, and during descent, when the ball is going down, the velocity is downward, acceleration due to gravity is downward, but the retardation due to air friction is vertically upward. We are assuming the magnitude of air friction is constant, so the retardation due to air friction is also same magnitude wise. That means during downward motion, acceleration can be taken as minus of g minus a in the downward direction. Now suppose this is the ground and the ball is thrown up with some velocity u, so it will go up, it will reach the topmost point and its velocity will become 0, and this is the case of ascent. And during descent, what will happen? From the same point the ball will come down and hit the same point on the ground, so the magnitude of displacement in both the cases is same. So for upward motion, let's use s is equal to vt minus half into acceleration into time square. So h is equal to 0 into t1 minus half into acceleration, which is minus of a plus g, and time taken is t1, so t1 square. So h is equal to a plus g by 2 into t1 square. So t1 is equal to 2h divided by a plus g square root of that. Now for downward motion, we will use s is equal to ut plus half at square, because u is 0, so it will make our solution easier. Displacement is minus h, u is 0, time is t2, acceleration is minus of a minus g in the bracket, time is t2, so minus h is equal to minus a minus g divided by 2 into t2 square, or h is equal to a minus g by 2 into t2 square. So we have t2 is equal to 2h divided by a minus g square root of that. So now we can find the ratio t1 by t2, which is equal to square root of a minus g by a plus g. So clearly this ratio is less than 1. So we have t1 is less than t2. Time of ascent is less than time of descent. So correct option is B.